Assalamualaikum warahmatullahi wabarakatuh. Hi everyone, my name is Rizal. So today I'm gonna present my research, my paper about an experimental study of hybrid solar and geothermal energy with applying heat pipe to enhance the performance of cacao beans drying process. The author of this paper is myself, Rizal Al-Faqih, Yohanes Gunawan, Nandi Putra, Iman Syah Ibnu Hakim, and Kukuh Trimargono. We are all from Applied Heat Transfer Laboratory, Department of Mechanical Engineering, Universitas Indonesia. So, the outline of this presentation consists of 4 sections. First is introduction, second is method, third is result, and last is conclusion. As we know, chocolate is the most favorite flavor in this world, and it comes from cacao bean. Cacao has long process to produce into chocolate that ready to eat, but the essential process is local processing. It is the first process of cacao processing. There are harvesting, fermenting, drying, packing, and transportation. But the quality of raw cocoa bean is affected by its drying process, because cacao bean should be dried in good condition to maintain of the quality. So, Indonesia, as the third largest cocoa bean production country, is really affected by this local processing because Indonesia has huge potential. So, the cacao drying usually use direct solar drying or called open sun drying. The commodity should be left on the ground and drying for 3 hours a day during daytime for 5 to 7 days. The open sun drying is widely used because it's easy to use and it free energy. But it depends on the weather condition. It can only dry on the sunny day, and it has longer drying time, and it can be cause cross contamination between the commodity and the air itself, and it causing intermittent effect that the commodity will reabsorb the water content from the air when the commodity is stored at the night. To solve this problem can be used any method that can enhance the drying process. The indirect solar drying has better performance rather than open sun drying because the commodity will be protected from the surrounding, so it will minimize the contamination. Because Indonesia located on the equator, it has more sunlight than other countries, so the solar energy can be utilized using solar collector. On the previous research, there are already one experimental study about utilizing geothermal energy of low enthalpy for drying using heat pipe heat exchanger. Because the solar energy can be utilized on the daytime, this research will be integrate the geothermal energy and solar energy so the drying can be done for 24 hours. And the purpose of this research are: first, knowing effect of integration solar energy and geothermal energy for drying. Second is faster drying time. Last is enhanced drying performance. The geothermal energy will be transferred using heat exchanger called heat pipe heat exchanger that can transfer amount of heat without transferring the fluid. heat pipe heat exchanger using 42 pieces with heat pipe that has staggered arrangement with 10 mm diameter, 700 mm length, water as working fluid, and 55% filling ratio. It also has fins, 181 pieces fins with aluminum material and 0.105 mm thickness. Solar collector used to trap and store the solar energy from the sun. It made from polyurethane sheet that contained black dove zinc galvanum sheet and covered by transparent plastic lid. So this experiment used several instruments to measurement and for data acquisition. The temperature measurement using thermocouple type key that connected to NI module. It plays on the inlet of solar collector and inlet of heat pipe heat exchanger, inlet of drying chamber, outlet of drying chamber, inlet of hot water fluid, and outlet hot water fluid. Then the relative humidity measurement using Autonix RH sensor. It plays on the inlet solar collector, inlet heat pipe heat exchanger, and inlet of drying chamber, outlet of drying chamber. It will be connected to NI module. Then we use hot wire anemometer to measurement the air velocity. Then the geothermal energy will be simulated using hot water that heated with 9 kilowatt heater that flowed by pump. This experiment has three different conditions. The first is hybrid solar geothermal energy condition, so the drawing done by solar energy and geothermal energy. The second is drying using solar energy only. The third is drying using geothermal energy only. So the initial condition of this experiment is, first, the commodity we use is cacao that has no fermentation process. It's dried after peel off, and it total 350 grams each for every condition, and initial moisture content is 45% to 62% with base. And for geothermal energy that simulate using hot water, the hot water temperature is 60 degrees Celsius and hot water flow is 18 liters per minute. And for the solar energy condition, air velocity is 0.6 meter per second, and the trial will be begun at the afternoon for each condition, and the experiment will be run for 24 hours for each condition. To analyze the experiment, that to calculate the performance of the drying we use is, first is effectiveness, used for calculate the effectiveness of the heat pipe heat exchanger that we use. Then the efficiency of solar collector. The moisture ratio formula is to calculate the initial moisture ratio and final moisture ratio of the experiment. The result of that experiment showed that the temperature profile, relative humidity profile, and radiation flux density profile. It showed that the temperature on drying chamber increased in sunny day caused by solar collector and heat pipe heat exchanger. The drying chamber temperature decreased a bit on the nighttime because the drying only run using heat pipe heat exchanger from geothermal energy on the nighttime. And the solar collector temperature almost similar to ambient temperature because the ambient temperature will be heated at the solar collector before it entering the drying chamber. And the relative humidity profile is really affected by the ambient profile. It shows during the night the RH is tend to be high because the temperature is low, and on the daytime the relative humidity is low because the temperature is increasing. The relative humidity on drying chamber is tend to be low even on the night time. It means the drying also run on the night time. So the drying on the night time can be minimize the intermittent effect. So the commodity will keep heated and not absorbing the water content from the outside. So the result data of drying using solar energy only has two profiles. First is temperature profile, relative humidity profile. So the drying using solar energy highly affected by solar radiation. The temperature on drying chamber will be rise during the day and it will be decreased on the night. So it can be seen on the solar radiation flux graph. The solar radiation on the daytime is fluctuative because it cloudy on that time. So it can be proved that the solar energy can be only used on the daytime and highly affected by the weather condition. And the relative humidity profile give same almost similar profile as the temperature profile. The relative humidity tend to be high on the nighttime and it's decreasing on the daytime. It shows the heat pipe heat exchanger effectiveness on hybrid solar and geothermal energy drying. The heat pipe heat exchanger effectiveness on it is 0.59 on average and 0.61 at the highest and 0.51 on the lowest. The moisture ratio curve shows the performance of experiment on three conditions: the hybrid with geothermal and solar energy condition, geothermal condition, and solar energy condition. So the hybrid with solar energy and geothermal energy has better performance because moisture ratio around 7% as qualification for dried cocoa bean achieved after 10 hours drying rather than solar drying and geothermal drying. The final dried cocoa bean almost fully dried, almost 100% of moisture ratio. The final dried cocoa of solar drying is around 28%, and for the geothermal drying is around 26%. So the conclusion are: first, the experiment of integration solar and geothermal energy for cocoa bean drying has performed. Second, hybrid solar and geothermal energy drying has best performance. Third is integrating solar energy and geothermal energy for drying that run 24 hours can avoid intermittent effect. Last is drying using solar energy highly affected by weather conditions.